Thank you very much. I would like to mention that I'm holding this presentation. I'm substituting my boss, Andreas Halm, which unfortunately could not be here. And we both represent a lot of colleagues which are here included and did a great work. So it's about copper ink and electrically conductive adhesives for future PV production. The content of the presentation is introducing us shortly, and motivation why using copper inks and silver staining strategies at PV production, as also in the previous talk, it will be a topic. Our current approaches for reducing silver consumption at cell level using copper ink, and also approach 2 by the reduction of silver consumption using electrically conductive adhesives, which is filled with a lot of silver, and it sounds like a paradox at the beginning. Some characterization procedures and a summary. So we are a non-profit organization founded 2005. The management board is on the left side, and most of the colleagues are here. Approximately 65 employees at the south of Germany, with a turnover of 7.6 million in 2003. We are involved, of course, in PhD programs, master and bachelor works. So we support a lot education, and we do educational trainings at all kinds of levels. We have a very consistent cell department, which develops a front-back contacted solar cell. We are now at TopCon level, and also as well a rear contacted solar cell called the zebra cell. We are now in mass production at 24.6%, and tendency, of course, raising. And since we are a research non-profit organization, we are not involved in mass production. We do as an end of our technology research approaches, technology transfer with successful patterns. So motivation for copper inks and silver saving in the PV production. I mounted here on the slide a common front-back contacted solar cell M10, which is 182 by 182. And it looks like that. It had on the front and the rear side a metallization grid, which is here gray, you can see. And also with a magnification here. We call these parallel lines the silver fingers, which were also more approached in the previous presentation by our partner from ISC, from Fraunhofer ISC. And these fingers must be, of course, connected perpendicular by so-called bus bars. In the past, they were continuous. Now, the most of the industry uses pad approach to save silver. So on these pads, the ribbons or wires made out of copper coated with soldering alloy or silver are soldered or glued to connect cells in the PV module. On the right side, you can see a tendency of the consumption of the silver in the cells, and the tendency as a technology roadmap. There are realistic values which are always correlated with industrial know-how and tier 1 products. And this is for an M10 size cell with 16 bus bar TopCon, which requires approximately 115 milligram silver. And that would lead to approximately 15.33 milligram silver per watt. And for a terawatt per year production, in which range we are and leading to beyond, we talk about 15,330 tons of silver per year. And to understand better the critical situation, here you can see we are in a phase which is really nice, and we are deploying renewable energies and also solar. And you see that by 2050, it's planned to go in the range, to have globally in the range of 60-70 terawatt installed. And at a production pace of 1,000 terawatt, we will not fulfill that. We need, of course, more. But you see that about 1,000 terawatt production annually, we are actually approaching 50% or demanding 50% of the entire world silver mining, which is a very big issue and which must be approached. It's not only about price, it's also about available resources. And looking on the right side, you see also the tendency of the price for the silver, and it is now at a very high rate. So a very good reason to go to substitutes, and copper might be one, because it's much more convenient than silver, 100 times less expensive, resistivity is in the same range, and it's 1,000 times more abundant than silver. So going to approach 1, let's see if we can put copper metallization on the solar cells. And with our partner Coprint, which developed a very nice and probably for most of you known product, they have a copper paste based on copper nanoparticles with rapid sintering at low temperature and